The first thing I'm going to do to solve this is I'm going to factor out a greatest common factor of x. Anytime you look at a polynomial and the last term has an x in it, that's kind of like an indicator that that's something you could factor out. So that's going to be our first step. I'm going to take every term, I'm going to divide by x. The reason I'm not dividing by a number is because if I look at 5, 17, and 12, those numbers don't have anything in common. There's nothing that I could divide out of all three other than 1, which doesn't really get us anywhere. So the first thing I'm going to do is take out this x, and I want to figure out what I have left over. So I should still have 3 terms, but all of my exponents are going to go down by 1 since I divided x to the first out of all 3. So I would have 5x squared plus 17x minus 12. So I now have one of my solutions, and that is because I can now take each part of this polynomial and set it equal to 0. So I have x equals 0. That's automatically one of my 3 solutions. And by the way, I know I should have 3 solutions because of my highest exponent here. But now I also have to take this part, 5x squared plus 17x minus 12, and set that equal to 0, and that's going to give me my remaining 2 solutions. And I know that because the highest exponent is x squared. So in order to solve this, I'm going to use quadratic formula because quadratic formula is a sure bet. I know for sure it's going to work. Factoring is maybe a possibility, and if you're really comfortable with factoring, you could possibly try it. But I kind of think that doing quadratic formula, since you know it's going to work, is your best bet. So let's identify A, B, and C. A is 5, B is 17, and C is negative 12. So I'm going to take those and I'm going to plug them into quadratic formula, which I'm going to write up at the top here. All right, so let's take these numbers and plug them in. So I have x equals negative b, since b is positive 17, it'll switch to negative, plus or minus the square root of 17 squared minus 4 times 5 times negative 12. And then it's over 2 times a, which is 5. All right, next thing I would do is take everything that's under the radical, so all of these numbers here, and I would put them in your calculator. No square root, just exactly how they're typed underneath, or how they're written, I guess. And when you do that, you're going to get 529. All right, now, because I'm a math nerd and I do this all the time, I happen to know that 529 is a perfect square. You may not have known that though. So what I'm going to do is rewrite this. Negative 17 plus or minus the square root of 529, and then it's over 10. So it's always a good idea when you're doing these problems, especially if it's a number you don't recognize, put it in your calculator and see if it is a perfect square. But if you didn't recognize that, you could do a factor tree and you would end up seeing that everything has a pair. And so, you know, you do get a perfect square. So I'm not going to do that part. I'm going to go right to this. So I have negative 17 plus or minus. When you do the square root of 529 in your calculator, it gives you 23. So one thing I want to really make sure is extremely clear. When you write down the 23, there is no radical. Once you take the square root, the radical is gone. So it's just the plain old number 23. Now at this point, because I don't have a radical and I don't have an I can split these up into 2 separate fractions and actually simplify them to figure out what is my final answer. So for my first problem, I'm going to do negative 17 plus 23 over 10, which comes out to be 6 over 10. And then if you look at your choices, because this is multiple choice, your answers are written as decimals. So 6 over 10 is the same as 0.6. So that's our second solution. Remember, our first one was x equals 0, which is over in green. And then I'm going to do the same thing, but I'll do negative 17 minus 23 over 10, which is negative 40 over 10, or negative 4. So now I have my 3 solutions. I have 0 that we got at the very beginning by factoring out a greatest common factor. And then I have 0.6 and negative 4 that I got from simplifying from the quadratic formula.